Okay, in this video I'll introduce you to some of the basic trigonometric, the derivatives of the trigonometric functions. And I've just listed them here without any proof because these are given in your formula booklet, and you can just refer to the formula booklet when these things pop up. So what it says is the derivative of sine x is cos x, the derivative of cos x is minus sine x, for tan x you get sec squared x, and so on. But just in case you're not sure what these trigonometric functions are, you probably remember the word SOHCAHTOA. SOHCAHTOA. So what it says is if I have a triangle, a right angle triangle, and if that angle is theta, then sine theta is equal to, so S is for the sine, then opposite divided by adjacent, so that's B over A. Opposite divided by hypotenuse, so that's B over C. Then the cos of theta is adjacent divided by hypotenuse, so that would be A divided by C, and the tan of theta is equal to opposite divided by adjacent, that's B over A. One of the simplest identities is that tan theta is equal to sine divided by cos, so sine theta divided by cos theta gives you tan theta. So these three here are, we can think of them as the most basic trigonometric functions. They are just the ratios of two sides of a right angle triangle. And these three here, the sec, cosec and cot, if you haven't come across them already, the sec is just is defined as 1 divided by cos, so sec x is 1 divided by cos x, and cosec x is equal to 1 divided by the sine of x, and you can probably imagine what cot x is. That's just 1 divided by the tan of x. These functions are defined as this. To prove that the derivative of sine x is equal to cos x is quite a bit tricky. It takes quite a while. So what I'll do for the rest of the video is I'll assume that these two are known. So I'll just assume these two, that the derivative of sine x is cos x and the derivative of cos x is equal to minus sine x, and try to derive these four. Now these are given in the formula booklet and you may choose it's not necessary, but I think it's a good practice in using the product rule and quotient rule and all that. So, and also to do with trigonometric identities. So if you are not familiar with the trigonometric identities either, then I'd say watch the rest of the video. Or if you think since these are given in the formula booklet you don't need to know how to derive them, then I just say skip and go to the next video. So what we'll do is we'll assume these two and try to derive the other four. Okay, now we had y is equal to sine x. Okay, so what we said was if y equals sine x, then dy over dx is equal to cos x. And similarly, if y is equal to cos x, then dy over dx is equal to minus sine of x. Okay, now we'll use this and try to find what the derivative of tan x is. So if I write y equals tan of x, now I showed that the tan x, one of the identities is tan x is equal to sine x divided by cos x. Now what I have here is a quotient. If you remember the quotient rule, if you have a function y equals u over v, then dy over dx is given by v du over dx minus u dv over dx divided by v squared. So in this case I get v du over dx, so v is equal to cos x. I have cos x times the derivative of the numerator, that's du over dx. So the derivative of sine x is cos x. So I have derivative of sine x is cos x. Then I have minus u. What's u? U is equal to sine x. So u is equal to sine x times the derivative of the denominator. And we know that the derivative of cos x is minus sine x. And all of that divided by the denominator squared. So that's cos x squared, that gives cos squared of x. Now I could rewrite the numerator as cos squared x. You can rewrite that as cos squared x plus sine squared x divided by cos squared x. And one of the first trigonometric identities we get as a result of the Pythagoras theorem is that cos squared x plus sine squared x is equal to 1. So this becomes 1 divided by cos squared x, and I said that 1 divided by cos is equal to sec x, or 1 divided by cos x is equal to sec x. So 1 divided by cos squared x will give sec squared x. And that is how we can show what the derivative of tan x is. Okay, let's also try to find what the derivative of sec x is. So if I have y equals sec of x. Now sec x is defined as 1 divided by cos x. So what I can do is I can use the quotient rule again. Remember, the quotient rule is once again u over v, same rule that I used earlier. So in this case, dy over dx will be v times du over dx. v is equal to cos x, but du over dx, differentiating 1, I just get 0. Then I have minus u times dv over dx. u is equal to 1 times the derivative of cos x will be minus sine x divided by the derivative, the denominator squared. So that gives cos squared x. So here I have minus times minus, that becomes plus. This term will be 0, so I get sine x divided by cos squared x. Now, although the derivation, finding the derivative is done here, I could rewrite this as, I can divide this into two parts. I'll write this as sine x divided by cos x times 1 over cos x. So this is still sine x divided by cos squared x, because now I can write this as sine x over cos x, that's equal to tan x, and 1 over cos x, and that's equal to the sec of x. So the derivative of sec x is tan x sec x. Okay, let's now go to the cosec x function. So let's take y equals cosec x. How do I derive what dy over dx is? So once again, the trick is to use the same rule as before. Rewrite cosec x as 1 over sine x, and then use the quotient rule, u over v. So once again, I get dy over dx is equal to sine x times the derivative of 1, which is equal to 0, minus the numerator times the derivative of sine x, which is equal to cos x, divided by the denominator squared. So that's sine squared x. Now this part becomes 0. I have minus cos x divided by sine squared x, but like I did in this case over here, I'll rewrite this as sine x times sine x, sine x times sine x, or sine x times 1 over sine x. So this would give minus, now sine over cos is equal to tan, so cos over sine is 1 over tan, which is also equal to the cot of x. So that's minus cot x, and 1 over sine is equal to cosec x. So this gives minus cot x cosec x. Okay, that leaves us with just one last one, which was the cotangent function, y equals cot x. There are two ways to do this. I could rewrite this as either 1 over tan x, or I think it's easy if we write this as cos x over sine x. Remember, one of the first identities I showed was that tan x equals sine over cos, so which means cot should be equal to cos over sine. And now use the u over v rule, or the quotient rule on this one again. So dy over dx will be equal to v du over dx, so that's sine x times minus sine x, so that's the derivative of cos x. Then I have minus cos x times the derivative of the denominator, that is cos x again, divided by the denominator squared, so that's divided by sine squared of x. Now then in the numerator I get minus sine squared x minus cos squared x. So what I'll do is I'll rewrite this as minus, I'll take a minus out and write this as sine squared x plus cos squared x. And you can obviously see why I've done that, because now this part here becomes equal to 1, because sine squared x plus cos squared x equals 1. Divide that by sine squared x. So this gives me minus 1 over sine squared x. But since 1 over sine is equal to cosec x, so I get this will be minus cosec squared x.